Name resolution in Microsoft Azure is a critical component of virtual networking that enables resources to communicate efficiently. Within an Azure Virtual Network, VNet, instances need to resolve domain names to IP addresses for seamless interconnectivity. By default, Azure offers an internal DNS service that fulfills essential lookup requirements. However, many organizations also integrate custom DNS providers for enhanced control. Understanding how to structure and administer DNS within a cloud environment provides a baseline for hybrid connectivity scenarios, as well as advanced features like private link services. Azure's name resolution services scale with organizational growth, ensuring that all resources, such as virtual machines, containers, and PaaS platforms, benefit from robust and consistent DNS lookups. This functionality is key to ensuring that new services can register host names accurately and that existing applications can locate dependencies regardless of their internal or external hosting setup. Within Azure, there are two main DNS resolution models: Azure-provided DNS and custom DNS solutions. Azure's built-in DNS server automatically assigns IP addresses, performs internal name resolution for VMs, and integrates seamlessly with Azure-based services. This approach is beneficial for quick deployments and ensures minimal administrative overhead, allowing for easy name resolution without specialized configuration. On the other hand, custom DNS solutions let organizations direct queries to an on-premises DNS or self-hosted DNS server running in Azure. This model is valuable for environments requiring advanced zone management, domain integration, or specialized features like DNS zones that automatically replicate across locations. Selecting the ideal model depends on specific application requirements, such as domain structure, resolution rules, and integration with existing Active Directory or corporate DNS infrastructures. Azure-provided DNS services require minimal setup. When a virtual machine is created within a VNet, Azure assigns it an IP address and manages hostname registration seamlessly. This allows resources such as virtual machines to refer to each other by hostname rather than numeric addresses. Each NIC is automatically configured to use Azure's internal DNS at a dynamic IP address, managed by Azure for internal name resolution. This solution simplifies initial deployments and generally suffices for basic environments. However, it does have limitations regarding custom domain names and hybrid integration, especially when corporate identity or directory services must be accessible across multiple environments. Also, compliance or advanced networking needs might demand control over DNS records and topology. Despite these constraints, Azure-provided DNS remains an excellent starting point, especially for small to medium-scale cloud deployments where minimal configuration is a priority. Custom DNS servers offer a flexible alternative when organizations require more control over configuration, security, and domain structures. Administrators can deploy their own DNS servers within an Azure VNet or utilize existing on-premises DNS servers via site-to-site VPN or Azure ExpressRoute. This approach allows customization of forward and reverse lookup zones, record management, conditional forwarders, and integration with Active Directory. By specifying custom DNS addresses in the VNet settings, each newly created resource inherits these named servers automatically. This arrangement is especially relevant in hybrid scenarios where virtual machines need to resolve machine names across on-premises and cloud environments. While custom DNS adds complexity, it can unify domain naming conventions, extend corporate identity architectures, and provide advanced debugging capabilities through DNS query logging and zone-level monitoring. Azure DNS is a dedicated hosting service for public DNS domains, allowing organizations to manage DNS records within Azure's global infrastructure. Azure DNS assures high availability and swift response times by distributing DNS data across Microsoft's named servers worldwide. Creating a DNS zone in Azure is straightforward. Administrators transfer the domain to a supported registrar, point the domain's name servers to Azure DNS, then version and manage resource records through the Azure portal, CLI, or APIs. Zone-level access control is enforced through Azure Resource Manager roles and role-based access control, RBAC. Additionally, this service seamlessly integrates with Azure DevOps or other CI/CD pipelines, enabling programmatic updates to DNS records as part of deployment processes. By leveraging Azure DNS, enterprises gain flexibility in managing their global presence, reducing latency for customers, and unifying domain management within the Azure ecosystem. Private DNS zones extend name resolution services to virtual networks without exposing records to the public internet. By creating a private DNS zone, administrators can manage domain names that remain resolvable only from within the organization's network boundaries. This is achieved through linking the private DNS zone to one or more VNets, enabling a private name resolution scope. This model is valuable for microservices, container-based workloads, and internal line-of-business applications that must not be publicly accessible. It also supports automatic registration of virtual machines' host names when using certain Azure-managed DNS solutions. Private DNS zones are integral to the development of layered network topologies that incorporate web tiers, application tiers, and data tiers behind private endpoints. As a result, businesses improve overall security while maintaining the convenience of DNS-based inter-service communication within Azure. Hybrid cloud solutions rely heavily on the consistency of name resolution between on-premises and cloud-based resources. In an extended environment, administrators often configure DNS forwarding to route queries involving Azure-based workloads through an on-premises DNS server. Alternatively, Azure DNS forwarders may direct queries targeting corporate domains back through a VPN or ExpressRoute connection so that they are resolved by the organization's internal DNS servers. This bidirectional arrangement ensures that on-premises systems can locate services hosted in Azure by name, while Azure resources can likewise discover internal Active Directory domains, custom TLDs, or specialized records stored on-premises. Efficient name resolution is particularly critical for domain-joined workloads, replication scenarios, and business continuity processes, all of which may traverse both on-prem and Azure networks. Proper planning in this hybrid space reduces latency, eliminates disjointed namespaces, and encourages consistent operational patterns across Azure and on-premises environments. DNS forwarding is a powerful mechanism that directs name queries from one DNS server to another for resolution. When dealing with Azure and on-premises networks, forwarding can link different DNS infrastructures, ensuring that each environment can resolve names in the other. Conditional forwarders are set up to handle specific domains or patterns, routing them to the appropriate DNS server. This approach is useful in scenarios where multiple domain names are split across different zones, such as internal corporate domains, third-party zones, and Azure-hosted domains. Administrators may deploy platform-based services, like Azure DNS Private Resolver, to federate name resolution across distinct networks. Through careful design, DNS forwarding allows organizations to unify their naming strategy so that all segments of the hybrid environment refer to resources consistently. This fosters a streamlined environment in which cross-service references are never hindered by unresolvable or duplicated domain names. Effective usage of DNS record types underpins successful name resolution in Azure and beyond. Common record types include records that map host names to IPv4 addresses, Quad A records for IPv6 addresses, and name record for canonical name aliasing. In addition, organizations use MX records for handling email routing, NS records to delegate authority to subdomains, and SRV records to specify service endpoint for applications like Active Directory or SIP-based services. With Azure DNS, these record types are configured through the portal, CLI, or API, enabling fine-grained management of the domain's resolution behavior. Meanwhile, private DNS zones also support these standard record types, though their scope is restricted to linked VNets, ensuring isolation. Deciding which record types to implement depends on each service's connectivity needs, whether for internal workloads, public-facing endpoints, or cross-environment solutions that blend cloud and on-premises infrastructures. Identifying and resolving DNS-related issues in Azure involves employing diagnostics tools such as Azure Monitor Logs, Network Watchers, and built-in metrics. Paired with DNS query logging, these services enable administrators to track query flows, measure latency, and detect unusual traffic patterns. In multi-layered networks, it can be helpful to configure distinct logging for public and private DNS zones to gain insight into where queries originate and how they propagate. Network Watcher's connection troubleshoot tool can verify that DNS name resolution is functioning by simulating communications between Azure resources. By analyzing results, organizations can uncover misconfigurations in NSG rules, misaligned DNS server settings, or missing DNS records that hinder name resolution. Automated alerts and dashboards can also highlight trends like sudden spikes in DNS requests or next domain responses, prompting faster remediations. Such visibility significantly reduces downtime and ensures that DNS remains a trustable foundation for cloud-based applications. Automation plays a critical role in maintaining consistent DNS configurations, especially in rapidly changing environments. Administrators can use Azure CLI commands, such as AZ-Network Private DNS Zone Create or AZ-Network DNS Records Set a add record, to provision and update DNS records in bulk. PowerShell also offers robust connects, including new AZ Private DNS Zone and new AZ Records Set, which integrate seamlessly into existing automation scripts. This programmatic approach facilitates continuous deployment pipelines, version-controlled configuration, and dynamic scaling of resources. By leveraging infrastructure as code (IAC) principles, DNS changes become part of the same release management lifecycle as virtual machine provisioning or network security group creation. This synergy minimizes manual errors and ensures that each environment, development, testing, or production, maintains accurate and up-to-date DNS records. Firms that standardize on CLI or PowerShell approaches gain agility in scaling application environments and drastically reduce the time spent troubleshooting inconsistencies. Securing DNS within an Azure environment involves multiple layers of protection. From a network standpoint, NSGs control which source and destination IP addresses can engage in DNS traffic. Often, administrators create inbound and outbound rules to permit only essential DNS flows. Additionally, private DNS zones reduce exposure by limiting record resolution to trusted VNets. Role-based access control ensures that only authorized individuals can modify DNS zones or record sets, preventing unauthorized changes that could disrupt services. Migrating sensitive workloads behind private endpoints, combined with restricting public DNS resolution, mitigates the risk of exfiltration or malicious scanning attempts. For externally facing DNS zones, Azure DNS benefits from built-in distributed denial of service (DDoS) protection, while advanced threat detection capabilities identify irregular traffic patterns. By combining these measures, organizations sustain the integrity and reliability of their DNS infrastructure, particularly in increasingly complex hybrid environments. Name resolution underpins many of the advanced networking features explored earlier, such as peering, user-defined routes, and private endpoints for Azure PaaS. By harmonizing DNS, administrators ensure that peered virtual networks exchange queries seamlessly, while user-defined routes can direct traffic to DNS forwarders where necessary. When configuring public IP addresses, domain names help external consumers locate services, tying in with Azure DNS or other providers to ensure consistent branding and discoverability. Security instruments like NSGs and ASGs often rely on host name-based filtering or at least require a robust name resolution policy for event logging and forensics. Similarly, Azure Bastion's connectivity benefits from stable internal name resolution, ensuring administrators can access resources reliably. Thus, configuring name resolution establishes a cohesive environment where each element within the Azure ecosystem interconnects predictably, reinforcing the reliability and agility necessary for modern cloud applications.